no thermal stress, hence no stress, because there is no restrictions. That's why there is no thermal stress. But suppose if I restrict it like this, and now, yeah, it is sigma is equal to E alpha delta T. That is 1. Now, this is a very simple concept, and if you go it, there are few couple of questions that asked in exams, but these are very easy questions, and don't worry about it. And now the next part is uh, shear force and bending moment diagram. Now, I hope you all go through it, means in BTech and your coursework. So, what is the shear force and bending moment? Suppose you have a rod. Before that, I need to explain the let me explain the support reactions. Okay, support reactions. In support reactions, first one is hinge support. Second one is roller support. Third one is fixed support. Okay. Now in hinge support, suppose this is a hinge, and you just place a body like this. Let me draw both things simultaneously. So this body has to cover reactions Ry and Rx. It does not have any movement because it is not restricting the movement. Means means the moment that is coming from the force. Suppose you apply force W, it has only two reactions. Okay, it has only two reactions on it. In roller support, that this is the case, here it can move in the y direction, and it does not have a registering actions to the movement, so it has only vertical ry dash vertical reaction. And in fixed support, it is like this. Suppose you clamp something in between a wall, and now you are applying load W. So here also there are one reaction, and just because it is hinged, it is restricted in all directions. It has one direction, two direction, and a moment. So Rx, Ry, and M. These are the three reactions coming in this picture. So this has two reaction forces, this has one reaction forces, and this has three reaction forces. So quickly write it down. So I'm going ahead. Okay, now going with these topics. Suppose you have a body. Suppose you have a body like this, resting on two things. Suppose this is a fixed support and this is a roller support. And you apply load, it will deform, and the reaction force at this point and this point, as you already studied in your mechanics class, you can obtain. Suppose this is W and this is in between L by 2 and L by 2. So R1, R2. As we know, R1 is equal to R2 is equal to W by 2. Okay. Now, what happens if we just the shear force in this, the shear force diagram is what is the internal reaction force that is coming in the rod. Okay, what is the internal reaction force that is coming in the entire rod, means it is drawn over a length. And bending moment diagram is what is the internal moment that is generating inside the body. Bending moment diagram is the internal movement that is generating inside a body. Suppose I will explain it here how this is coming. Suppose this is your body and you applied W force. Here is a reaction force. Okay. Now this is R1, this is R2, and and this is, if we draw it like this is R1, this is R2. Now you know that this reaction force R1 is W by 2, and this is also W by 2. Now what is the reaction force here? Because I divided in two parts. There is some support forces that should be in between. So suppose this is a shear force and this is a moment, and here this is a shear force and this is a moment. Now what is the shear force diagram? What is the shear force diagram in this? You draw it like this, and along the length the upward reaction force is W by 2. Okay, but here if you just balance this is tau 1. Suppose this is tau 1. Now tau 1 minus W by 2 is equal to 0. That means tau 1 is equal to W by 2. Okay, means at any point here you also take, just here also take, because it is in upward direction and negative W by 2 force is acting to balance this part. So this is a W by 2 part acting on the surface, and it is whole along. Suppose if I move from this end to any end, it is W by 2 constant. How? Suppose I move here also. Here is W by 2. You have to take only one portion. Hello, can anyone respond? Hello. Okay. So, sorry, there is a. So I am getting again where I was. So suppose you do a reaction force. Uh, you just find you just take it as a W1 by 2 and draw it and take any part, and just you have one force W by 2, and here this is the shear force direction. So this will come positive, that is W by 2, and as you move up to the point where W is acting, it is W by 2. Now if you move ahead, you have one force W and one force W by 2, and your shear stress direction is this. Now if you take this one, tau 1 plus W minus W by 2 is equal to 0, then tau is equal to minus W by 2, means it will go like this, and again whole length the value is same, means it is minus W by 2 at this point. This is a shear force diagram. Now suppose there is another case. I am taking another case. Suppose you have a beam that is supported, okay, uh, at 2 kilonewton here, 4 kilonewton here, and this is 1 meter, this is 1 meter, and this is 0.5 meter. Okay. Now, what will be the reaction force? Can suppose this is 1, this is 2. What is R1 and what is R2? R1, if we compute, it will come 2.8 kilonewton, and R2, if you compute, it will come 3.2 kilonewton, and their total sum is 6 kilonewton. Now, their shear stress diagram, if you shear force diagram, if you want to draw, take this element, take this 1 meter element before the force is acting. Suppose I take this one element, here the force is coming 2.8 kilonewton, and here is tau 1. Now, this tau 1 is, or just called it SF, this is shear force. This is positive in direction, and it is 2.8, and up to the next force, that is 2 kilonewton, it is acting, it is equal to 2.8 kilonewton, because if you find it at any place here, it is 2.8 kilonewton, but when it reach 1 meter length, there is 2 kilonewton force acting. Now, if you take that part, and here it is 2.8, here it is 2, then what should be the shear force here? SF. Calculate SF. SF is equal to 2.8 minus 2, that is 0.8 kilonewton. It will come downward like this, and then it will again move up to the next force is coming, same value, because if you take any section, it will go like this. After this, there is a force called 0.5 meter, there's force called 4 newton, 4 kilonewton. Take this element here, take this element here, let me change the pen. Take this element here, you can see this. What is the shear force? Suppose this is a backward direction SF. Now SF is SF plus 4 plus 2 minus 2.8. Then SF is equal to 0. What is SF? It is around, you can just 4 to 6, 4 plus 2, 6, 6 minus 2.8. It is minus 3.2. It is 3.2. Okay. But it is in negative direction because it is here plus, so it is negative direction. Now it will come like this, minus 3.2. And again up to the next force, it will go like this. And at this point, it will again 0. Why? Because if you calculate everything, then you will get. So this is the two shear force diagram. Uh, Anyone have any problem? Just ask, or I will go with another example. Hello,
So 3.2.
hello.
So have you got 3.2, sir?
3.2. So what? Let me take an element here. You are seeing this point, okay? Now SF at this point, it is in negative direction. Take this direction as a direction of plus 4 kilonewton. That is also in negative y direction, plus 2 kilonewton, and minus 2.8. That is here. That is reaction force that is coming. So that is equal to 4 to 6, 6.0 minus 2.8. It is 3.2. Okay. Now SF plus 3.2 barabar 0. SF is equal to minus 3.2. Now it is clear.
Yes, sir.
Okay, I will go with couple of examples in circle because here is a very lengthy topic. I need to devote more time in this. So suppose okay, suppose this is a beam that is acting W. This is reaction force R1. This is force R2, and it is acting with UDL. Suppose UDL. Okay, UDL, that is W per meter. That is small w. That is small w. Okay. Now this length is L, and we have to obtain the shear force. Now, suppose what is the reaction force? Everyone know study mechanics. Then R1 is equal to R2 is equal to WL by 2. Since because of symmetry, if you want, I can obtain R1 and R2, but R1 and R2 is equal to W into L, and R1 into L is equal to W into L into L by 2. So it will come R1 is equal to W L by 2. I hope you remember these things. So R1 equal to R2 is equal to W1 by 2. Now, the shear force diagram, it is little tricky. If you see that, suppose uh, this is your reaction force, and here you have a beam. This is R1, that is WL by 2, and it is W. And if you take any arbitrary distance x, can what is the shear force? Suppose this is the direction of shear force, SF, that is the positive direction. Now SF plus this W is acting, okay. Now W is acting at x direction. So W into x is the total length, is total weight. If you multiply it, it is per unit length. If you multiply it with the x, that the weight that is acting over the span is W into x minus WL by 2 is equal to 0. Then what is the SF? WL by 2 minus WX. Okay. Now it is a function of x. So x is this distance. What if x is equal to 0? Suppose this is x equal to 0. X equal to 0 means it is WL by 2. And when x is increasing, it is going on decreasing like this. And at middle point, when x is equal to L by 2, the shear force is 0. And again, the second portion dominates and it will go on decreasing. And this is your shear force diagram. And this is again WL by 2. Now, anyone have problem in this figure? Okay, someone is getting something or nothing. Can someone please say? If you don't get, then I will again explain. Type in message at least. Okay. So for yeah, this shear force is clear. Now I am going with another question because this is the most important. Every time get asked two questions from this topic only. Every time. That's why I am taking time in this shear force. Suppose you have this portion A, B, and it is 6 meter in length, and your half portion is UDL, uniformly distributed load of W per unit length. Okay. Now you have to obtain the shear force diagram SF. Okay. Now first of all, reaction force RA and RB we need to find. Then what is RA? I am writing it directly. Please solve it on your own. Kilonewton, and RB is equal to 11.25 kilonewton. Now, our first intention is to know how to draw shear force diagram because you know how to find the reaction force. This is x is equal to 0. This is x is equal to 6, and the reaction force is half distributed 3 meter. Now, what you should do is take any element at distance x. Okay. Now this has 3.75 kilonewton. Oh, it is 5. Sorry, it is not. I have not written. It is 5 kilonewton per meter. Okay. Now, so take this element before 3 meters. That is, no any load is acting. Suppose this is the element. Here it is acting with 3.75, and take this diagram. This as shear force as a positive direction. When shear force minus 3.75 is equal to 0. Shear force is equal to 3.75. Now 3.75 is coming like this, and up to 3 meters, because no force is acting, it is equal. Up to 3 means same. This is 3 meter. And after 3 meter, the load is acting. Now take any arbitrary section at x. Okay, at distance x. Then at any distance x, what is the shear force? Suppose this is your position, this is your 3.75, and suppose you take any position x here. Now solve this for this shear force. SF plus, if you take x as a whole, no, suppose x from here only, and it is 3. Don't take as a whole. SF plus W into x, okay, then minus 3.75 is equal to 0. SF is equal to 3.75 minus WX, and W is 5. So 3.75 minus 5x. Now if you put x is equal to 0, that is at the point of 3 meter, it is 3.75 we are getting from it. But after that, there is a decrement, and that will decrease like this. I just go like this. It will decrease like this. Because this is a equation of a straight line, so it will decrease like a straight line. And this is a point where shear force is 0. Now the question is, where the shear force is 0? Put SF is equal to 0. That is equal to 3.75 minus 5x is equal to 0. Then x is equal to the distance that came. What is the distance? Can anyone say? 0.7. X is coming as 0.75. I think. If not, then check this. Okay. So this is the position 0.75. And if you add 3, it is 3.75. Now this will decrease. And what is the shear force at this point? This is the maximum shear force, and this is equal to SF is equal to 3.75 minus 5 into, this is again 3. The whole length is after this is 3. So this will come as 11.25 kilometer. So this value is 11.25 kilometer. Okay. Now going with another question in this same thing. Anyone had doubt in this question? Hello. Any doubt? Can ask. No one is replying. I'm not audible or what?
Audible, sir.
Okay. Are you getting these things or not?
Yes, sir.
Okay. Now the next question is, suppose you have a beam. Okay. Now suppose you have a beam. This is A, this is B, and this is a portion, and here a load is acting. That is C and that is D. Now this is 1.5 meter. This load is 4 kilonewton. This load is 2 kilonewton per meter, and this is 1.5 meter length, and the whole length is 4 meters. So this is 1 meter. You have to make the SF diagram. So first of all, RA and RB, that is, any data is missing? No. So RA is oh sorry, equal not. This is not symmetric case. RA is equal to 3.5 kilonewton and RB is equal to 2.5 kilonewton. Now I am giving you 2 minutes to try this question. If you are getting it, okay, then I will. Otherwise, I will solve.
What is the CD distance, sir? 1 meter.
Yeah, yeah. Middle distance 1 meter. Okay, I am giving you 1 minute or 2 minutes. Hello. So anyone tried it? Can anyone guide how to start? My pen will be what you will say. Please say something. I will draw this here. Can I start? Okay, let me draw. Then RA is 3.5 kilonewton and up to point C there is no load. Hence, it will be a rectangle like just I drawed earlier. And at point C, you have a load and that load is 4 kilonewtons. So this is 3.5 kilonewton and this is 4 kilonewton. So it will go in the negative direction of 0.5. Now after 0.5, you have a again decrease, again load that will decrease. Then it will be like, it will go like zero point 0.5, zero point 0.5 minus zero point 0.5 minus 2 into x. Okay, then it will go like this up to d, and at x equal to 1, it will be minus 2.5. Now after 2.5, there is no load is acting and it is constant and it is equal to 2.5. Then shear force is equal to 2.5 in negative direction. Okay, so how many of you, anyone got this answer? Please unmute yourself, say something, because otherwise I am like talking to all. Okay, Okay, these are the things that you need to practice. Otherwise, you will not get it easily. It needs time.
So once again, till last point, sir.
Yeah, yeah. Tell me.
2.5.
Hello.
Yes, sir. How you got 2.5, sir? Minus 2.5.
Oh, minus 2.5. So you know you are clear with this point. Here it is constant. So it is a rectangle. Okay. Now here, why how I got so? Suppose just take this adjacent point before this is acting starting here. Now take this point. Add this just load, and before the usual x, take this point. Okay. Here it is coming 3.5. Okay, here it is coming 4 kilonewton, and suppose util doesn't start acting at this point only, then it will be shear force SF plus 4 minus 3.5 is equal to 0. SF is equal to minus 0.5. Okay, now here you got minus 0.5. Now at this point, suppose at x you want to obtain. So at this point you have one force, reaction force. Here this force is this is 3.5, this is 4, and this is again 2 into x. Now SF equal to, suppose this is the direction, SF plus 2 into x plus 4 minus 3.5 is equal to 0. Then SF plus 2x minus 0 plus 0.5 is equal to 0. SF is equal to minus 0.5 minus 2x. I hope you get it now how I came with this value.
Yes, sir.
Okay. No, so that is enough for the shear force. You will question it again. Then I will end up. Now I am going with bending moment diagram. Bending moment. Suppose just take the above example. This is a rigid support, and you apply W load. This is R1, this is R2, and this is L, and it is acting at the center. Then just what I said is this is the convention. This is positive, this is positive, and in the right hand side, this is positive, this is positive. Now take this moment as positive. Suppose the reaction force is W by 2. Na? Okay. Now take this element. Here it is coming W by 2. And do have a moment like this. Now suppose this is M. Now this is M, and now it is coming in opposite direction to this. Then it will be minus W by 2 into X. It is at distance X. So at this point, the summation of the moment is, that is M plus W minus W by 2 into X. That is equal to 0. Here the moment is W by 2 into X. Okay. Did you get it? Hello.
Yes, sir.
Okay. Now suppose that is the now draw it on the bending moment diagram. Bending moment diagram. At x is equal to 0, the bending moment is 0, but it will go on linearly increasing and then decreasing. Why decreasing? Let me show that to you. Okay. Now what at x by 2, what is the moment? W by 2 into L by 2. That is equal to WL by 4. This is at the center. That is WL by 4. And if you go after W by, suppose this is your rod, this is W by 2, this is W, and take now this moment M. Okay. Now M And suppose this is x, only this is x, this is L by 2. M my M plus, because it is also acting in anti-clockwise and it is also acting in anti-clockwise, M plus W into x, and it is minus W into L by 2 plus x, that is equal to 0. M plus Wx minus WL by 2, let me say it is, the x is not come, okay. At any point at x should be coming form of x minus Wx minus WL by 2 plus x. WL by 2 minus x is equal to 0. And it is coming WL by 2. No, that should not be okay. Wait a second. Let me. Wait, I'm drawing new. There is something. Suppose you have a rod and it is acting like W by 2. Here W, and this is L by 2. And at center you obtain WL by 4. Okay. Now take this element and it is a distance x. Suppose this is distance x. Now this is a positive moment M. So M plus W into x minus L by 2 minus W by 2 into L by 2 is equal to 0. M plus Wx minus WL by 2 minus WL by 4, that is equal to 0. M is equal to WL by 4, WL by 4 minus Wx. Okay. So this is your now what happened at x equal to 0 means at x equal to 0 means at the midpoint. At x equal to 0, moment is WL by 4, and after that it is gradually decreasing, and at x is equal to again L by 2, if you just uh, okay, now it will gradually decrease and it will gradually decrease to 0. So this is how the value is ending here in the negative y direction. Now in next question, uh, suppose this the earlier example, this is 2.8 kilonewton load is acting. Here also 2 kilonewton load, 4 kilonewton load, and here it is 3.2 kilonewton load. This is 1, this is 1, and this is 0.5. This was the above question. So we obtained the shear force diagram. Now we are going to obtain the bending moment diagram for the same case. Okay. Suppose if you draw, take the moment about this point. What will be 2.8 into x, and it will gradually increase. So for this point, the moment is 2.8 into x. So it will increase like this up to 2 kilonewton. After 2 kilonewton, it is like suppose I take after 2 kilonewton this point, and here it will be, this is the direction positive m, and if you take whole at as x, yeah, suppose this is as x, m plus 2 into x minus 2.8 into 1 plus x is equal to 0. M plus 2x minus 2.8 minus 2.8x is equal to 0. M plus 2x, sorry, m is equal to 0.8x plus 2.8. Now at x equal to 0, it is 2.8, but as x increases again, it will increase, but now it will increase in an is different slope. Here the slope is 2.8x. Here it is 0.8x. Now it will increase like this. Okay, up to 4 Newton. At 4 Newton, now again, take this element. Bending moment diagram, same thing. 2.8 to 4. Now here it is, distance is 1. Here the distance is 0.5. And now take any element x. And here the direction is positive. M plus 4 into x, because it is clockwise movement, getting positive 4 into x plus 2 into 0.5 plus x. The same, it is getting positive minus 2.8 into 1.5 plus x is equal to 0. And if you solve it, it will be m is equal to 4x minus 2.8, 6. Let me solve it. M plus 4x plus 1 plus 2x minus 2.8 into 1.5 minus 2.8x is equal to 0. Then m plus, this is 6x, 6x minus 2.8 is 3.2. Then the moment will come is minus 3.28x plus 2.8 into 1.5. Okay, so at x equal to 0, it is 2.8 into 1.5. Okay, now after that, it will decrease because the slope is negative, minus 3.2. And it will decrease because after two load is acting, it will decrease like this. And at x is equal to 1, you can say that both are equal. So I hope you are getting this. So this value is maximum value up to which the load is acting. Then again it will, so let me write the maximum value. It is 0, it is 2.8, it is 3.2, and again it is 0. Okay, this is 1, this is 0.5, and this is 1. Now ask if anyone has problem. If you are not understanding, then also tell me. I will repeat it again, but please tell how you are getting it. Any message? I'm waiting. Yeah, tell something.
So,
Yeah, tell.
so the previous sum, the
Okay.
last step alone, sir.
Okay.
M is equal to little more down, sir.
Okay.
Yes, sir. Here only, sir. The last one. M is equal to WL by 4 minus WX. Can you explain that alone, sir? The last step.
Oh, wait. Give me a sec. It is not W. If you add it, what it will be? That is 4. It is 2 plus 1, 3. I think. Wait. Just there is a confusion. WX minus W by 2 into. Sorry. X minus L by 2, and it will be X. I think it will be X right now. Yeah, because it X, I am taking X as a whole. No, so the moment will be W by 2 into X. So M plus WX minus WL by 2 minus W by 2 into X. Okay, so M plus W by 2 into X minus WL by 2 is equal to 0. M is equal to WL by 2 sorry, this will be W into L by 2, and this is W by 2 into X. So M is equal to W by 2 minus W by 2 into X. Now it is okay or not? Uh, you have to take the moment actually. I'm getting some error in this. Why I'm getting, I don't know. Can anyone say why I'm getting this error?
So the WX also missing.
Yeah, I'm seeing where I'm getting the error. Suppose this is, let me see there. Okay, let me do it again. If this will not work, then I will tell you in next class why I'm getting it. So suppose this is your, suppose this is your load W by 2. This is your W at L by 2, and this is a certain point that I am asking to calculate the moment M. Now this is distance X. Suppose this is distance X. Let's change the, now M at X plus this is W. Now W into X, that is the load that is acting in clockwise direction, and now it is acting in opposite direction. So minus W by 2 L by 2 plus X is equal to 0. Mx plus Wx minus Wl by 4 minus W by 2x is equal to 0. Now sorry, mx plus Wx by 2 minus Wl by 4 is equal to 0. Mx is equal to Wl by 4 minus Wx by 2. Now I am getting it right. Okay. Now, are you getting it? The question was.
Yes, sir. Clear, sir.
Now this is value, and now if you put x is equal to L by 2, it will equal to 0. Okay. And okay, anyone else has problem in the next question? In this question, because now I am because 1 hour left. Now I am trying to ask you. I am trying to give you some question, or everyone has previous year book question paper, or you have books in your write in chat box. You have all of you have books. You have previous year get question paper or book or anything where you, from where you are writing questions. Can anyone respond? Hello, am I audible? Do you have books of previous year gate, previous year ESCs? Okay, then try to solve the basics of strength of material, that is stress part, strain part, and also go and solve with shear force and bending moment diagram. Okay, means try to solve it. I know it is a little bit difficult. The first time you will not get so easily, but try to, because if you won't try, then it will end up again doing the same. You will end up losing what to do. Now I am going to add something so that the question can be easily solved. So suppose I'm going to talk about stresses, and in that part, a few different like self-loading condition. Self-loading condition. Okay, this is a stress problem, stress strain problem. This is not shear force and bending moment, because it will come in between the problem, and you will again say, sir has not made you. So suppose you have a body that has its own weight. Suppose you have a body that has its own weight, okay, W, that is mass into G, and it is hanged. Then what is the elongation in the body? That is the question. How you solve it? Now, if I uh, in the formula, that direct formula, if you want to, I can give you WL by 2A. But I want to emphasize you how it came. Okay. Now suppose if I take this elemental strip dx, okay, this elemental strip dx, and before that, below that, it has a length x. Is everyone with me? Because I'm, please try to see what I'm trying to do. Okay. Now, what is the elongation in this element? Because of this part, because of this load. Suppose this is a separate element, and because of this load, what is the elongation? Suppose this is the area cross section is E, A, and E is the modulus of elasticity. Now, what is the elongation of dx element? That is d into dx upon a into E. Sorry, dx. Okay, P. Now, what is P? Can anyone say P? P is actually the load acting on this portion. This is the load that is acting, and this is the P that is force is acting here. So the weight of the body. So, no, but it will not mg because I am taking elemental strip. So it will not mg. Okay. Suppose this whole length is L. Okay. So divide whole mass by L and then multiply it with X. W by L. This is the elemental weight. Okay. Now multiplied with X so that this mass, the weight of this part is gained. Now this part is only responsible for elongation of this dx element, and now multiplied with the x by E. Everything is same, but just put P is equal to WL by X. Okay. Now this is the elongation of this dx element, W by L into E x dx. Now, if you integrate this element, this dx element is a delta for this. Now, if you want to obtain for the whole of length, then what we have to do is take the x from 0 to L, and here the 0 to delta L. When load is 0, means when x is 0, the load is dead. So this will come into like this. Del L is equal to WL by E x square by 2 x dx integration with that x square by 2 0 to L, and now it will go with W L by E into L square by 2, and it will be W sorry, where is A went? Oh sorry, I don't write A. So WL by 2AE. Okay. So I hope you got it, that in normal conditions, suppose this is a part and you just have a, and you will apply W weight, then the delta L will be WL upon AE. But in self-loading condition, this is that W, now that delta L will be WL by 2AE. Is it okay with everyone? Now let okay. Now let move with other problem. Suppose, okay. Now suppose this is delta L equation. Na? Delta L is equal to PL upon AE. Now there are two. Suppose you know P, you know L, you know these two quantities, and you obtain delta L. Okay. Now what if these two are unknown? How to solve it? Means suppose there are two unknowns in the same equation. How to solve it? And that is called indeterminate problems. Indeterminate problems. Okay, now I'm giving you example. Suppose you have a you have a let me okay. For this one part and two part, the properties are suppose length L1, A1, E1. Okay, length L2, A2, E2, and suppose this is connected with a bar. Okay, now a load P is acting, and you need to find the what is the total elongation or the reaction force in each material. What is the part of P1 that is going here? What is the part of P1 that is going here? As you know, both are different materials. Okay, now you know that here delta L is also unknown, also not known, and P1 and P2 are also not known. But if you look at the question, here a condition is this rod remain horizontal. What is the meaning of this? This rod should remain horizontal means that the elongation in one should be equal to elongation in two. This is the condition, compatibility condition. This is called compatibility condition. Okay. Now delta L of one will be P1 L1 upon A1 E1 equal to P2 L2 upon A2 E2. And in this form, we obtain P1 and P2 relation. That is L2 by L1, A1 by A2, E1 by E2. Now, and we all know P1 plus P2 is equal to P. So we have two equations, two unknowns. We can solve for P1 and P2. Okay. Now this is the first indeterminate problem that need to be solved with a given condition. Okay. Now I'm going with to the second problem. Everyone is okay with it? If any has question, ask me. Should I move ahead? You are not. Yeah, everyone is not typing any message. Yeah, this is not. Just type message. Yeah. If you are not speaking. No. Okay, I am moving ahead now. Next question. Suppose you are given two bodies, one body and second body. Both are different bodies. This is one body and this is second body. And this is suppose this has A1 length, A1 alpha 1 that is thermal coefficient and E1. This has A2 alpha 2 E2 and it has length L. Now, so here it is given we increase the temperature delta T. Okay, and suppose alpha 1 is greater than alpha 2. Now, what is the stresses in both the sections? Yeah, or what is the total elongation? Total elongation or stresses. Uh, any idea how to solve it? Anyone can suggest anything? Okay, let me go. Am I audible or not? Nothing is coming now. Message, nothing.
Audible, sir.
Okay, let's say something. I need to wait otherwise. Now suppose if we take two different objects at different time, what will be? And it is given that it is glued in between. Okay, glued. Now take this body, the upper body. Now the elongation will be delta L is equal to L1 alpha 1 delta T, and below the material will be, it will be delta L is equal to L2 alpha 2 delta T. Now it is given that alpha 1 is greater than alpha 2, means delta 1 is greater than delta 2, means this will elongate more and this will elongate less. But as you know, this is glued. Glued means it will not separate. Okay, both will go side by side. So the condition is, suppose the first part, this is the first part. The first part want to move this much, but end up moving this much. Second part want to move this much, but it will end up moving this much. Hence, the final length will be equal. This is the first case. Means, if I okay, now this is the suppose this should be delta L1, but it will end up only this, and this should be delta L2 this much, but it forces the material to go there. Okay, now we can suggest the same problem as this length is reduced by applying a force, compressive force, and this length is increased by applying a tensile force. And suppose that this force is P. Okay, now suppose that this force is P, and if we apply the same condition, so what will be this delta L? This delta L will be delta L is equal to L1 alpha 1 delta T minus PL upon AE. Okay, A1 even, sorry, L1 even. Delta L is equal to L2 alpha to delta 2 plus P L2 upon A2 E2. Now this is equal, but this P length is trying to reduce its this length, and this term is trying to increase its length to this much, so that the final length will be equal. That means L1 alpha 1 delta T minus sigma L1 upon E1 is sigma 1 L1 upon E1 is equal to L2 alpha to delta T plus sigma 2 L2 upon E2. Now if we transpose that part, sigma 1 L1 upon E1 plus sigma 2 L2 upon E2 is equal to L2 alpha to delta 2 minus L1 alpha 1. Oh, sorry. Equal to L1 alpha 1 delta T minus L2 alpha to delta T. And initial length is given, it is equal. So means L1 is equal to L2. That is L1 is equal to L2. That means sigma 1 by E1 plus sigma 2 by E2 is equal to alpha 1 delta T minus alpha 2 delta T. That is equal to delta T alpha 1 minus alpha 2. So I hope you get it. Hello. Hello.
Yes, sir.
Now it is okay with you? Type in message if you are doing type message. So you got this problem, the composite material problem, how to solve it. Both are two different materials and we need to solve it. At least type message, how can I know you are getting it? Okay, yeah, you should type message here. Now, this is the point that this this is the another case in thermal stress interintimate problem. Okay, one is just look it up as well. Now, so let's go with some more concept about suppose you have a body. This is about longitudinal strain and lateral strain. Longitudinal strain and lateral strain. Okay. Now suppose you have a three-dimensional body. Okay. Now you have suppose you applied sigma 1 in in this phase. This phase. Okay. I should do this. You are getting where I am applying sigma 1. Now you need to find out the how many direction there is longitudinal strain. Longitudinal strain. How many direction and what are their values? Wait. Okay. Now longitudinal direction. How many directions and what are their values? What are their values? And lateral direction, in how many direction the strain is coming and what are their values. Okay, now please follow me because it is going a little bit in 3D, so if you miss you will end up, suppose this is sigma 1. So let me look at. Okay, now suppose this is sigma 1, so in the direction of force there will be a longitudinal strain, or that is the change in length. Hence, it has only single direction. Therefore, longitudinal strain will be in only one direction, and it is delta L is equal to sigma L upon AE, or delta L upon L is equal to sigma by E, or sigma by E. Now, lateral strain. In how many direction the lateral strain is coming? Can anyone say? Any guesses? Okay, lateral strain comes in the uh, direction other than the direction of applied force. Now, if it is in x direction and you have other two direction, that is y and z. Now you can see that in y direction there is a lateral strain and in z direction there is a lateral strain. Hence, lateral strain comes in two directions and their values are delta L lateral upon L is equal to mu times sigma by E. Okay. Now, any problem in this concept? Let me give you a little bit. Suppose you have a two-dimensional body and you apply in both sigma 1 and sigma 2. It is a two-dimensional body. Then what is the value of strain in one and two direction? Can any guesses? If everything it is in dimension, it is L equal L L and E is same. Any guesses? Okay, let me tell you. In because of this epsilon 1 in x direction, in one direction I am talking about. One direction, that is in along sigma 1. In one direction, what is the strain due to sigma 1? That is epsilon 1 is equal to sigma upon E. Okay. Now, because of this epsilon 2, another strain is coming, that is called lateral strain in one direction. Now that will add to mu times sigma 2 by E, that is negative. Now in second, epsilon 2 is equal to sigma by E, sigma 2 plus minus mu times sigma 1 by E. Because if we consider the strain in this direction, then this force will cause this component. Okay, and this force in this direction will cause this component. This is clear to everyone? At least write in chat box. Is everyone sleeping or you have eaten very much? What is happening? I know it is difficult for you to sustain 5 hour class, but what you should do? At least type some message so I know you are awake and I need to teach. No messages coming. I don't know what to do. Yeah, yeah. Say something at least.
Yes, sir.
Okay. Now, so now in three dimensions that I know that you know. So I will extend this concept that I told earlier in three dimension. Okay. Now this will help you in finding the volumetric strain. Okay. Now suppose this is working with sigma 1, this is working with sigma 2, and this phase is working with sigma 3. Now, in one direction, epsilon 1 is equal to, I hope you are getting it. If not get, please message me. Minus mu times sigma 2 by E minus mu times sigma 3 by E. Epsilon 2 in second direction, sigma 2 by E minus mu times sigma 1 by E minus mu times sigma 3 by E. And epsilon 3 is equal to sigma 3 by E minus mu times sigma 1 by E minus mu times sigma 2 by E. Okay, you know where I'm getting this relation? Can anyone help me to get where I got this relation? Okay, let me go with it. Now, what is the, suppose this is X, this is Y, and this is Z. And suppose it is L, L, B, H. This is the volume of this body. So volume is equal to L, B into H. Okay. Now what you have to do is take log both sides. Log V is equal to log L plus log B plus log H. Then differentiate it. It will be dV by V is equal to dl by L is equal to dB by B plus dH by H. Now, if you can just, this is a strain in each direction and their values are here, epsilon 1, epsilon 2, epsilon 3. So just if you put it in this way, then it will be sigma 1 by E minus mu times sigma 2 plus sigma 3 plus sigma 2 by E minus mu times sigma 3 plus sigma 1 by E plus sigma 3 by E minus mu times sigma 1 plus sigma 2. So now the value is 1 by E sigma 1 plus sigma 2 plus sigma 3 1 minus 2 mu. That is delta V by V, change in volume. This is change in volume divided by original volume, and this is called volumetric strain. Now apply the concept. I told you that mu should be less than 0.5, less than or equal to. Apply mu is equal to 0.5. What is will be the value? If you apply mu is equal to 0.5, then it will be 0. Then change in lateral volumetric strain would be 0. Means the volume will not change on applying stress in all directions. Okay. Now this questions came, how you obtain zero volumetric strain. Then the condition, the one condition can be 0.5. If mu is equal to 0.5, you can get volumetric strain is equal to 0. Is it okay?
Yes, sir.
Okay. So this one concept, and let me I cannot start new topic because time is going up, and then you will all, and all also it is getting more than the your limit, because everyone has limit. So let's talk something. Let me see if any problem I can give to you. Okay, I think if everyone has book, they can go with basic stress question, basic stress and strain uh, in the weekdays, basic stress and strain, thermal stress and strain, shear force and bending moment, and shear force and bending moment, and question on indeterminate problems. Indeterminate problems. Okay, and I suggested I given you my mail ID. Did you have? Let me type again. This is my mail ID. Alex dot isc. Sorry, at the rate isc dot ac dot in. Mail me if you have any problem. Okay, and also take it for future because you can ask me anything. Okay, please note it down. If you have any question, any query, mail me here. Now, there are a few things that I want to discuss. These are basic things. You can just, yeah, remember it. Okay. So, few things that I want to discuss. Okay. Now, various materials, and stress strain curve. Suppose you have a rigid solid, that is rigid body, that is we study in mechanics. What is their stress strain curve? Can anyone just say in just one line what is the stress strain curve? Just say in one line what is the stress strain curve for rigid body? At least type in message. Any guess? Yeah, engineering curve, stress strain engineering curve for rigid body. Yet we study mechanics. Straight line. Okay, straight line is a very general term. Which straight line? So let me go with it. Okay, because in rigid body there is no strain, but there is stress that I told in the first lecture. But there is stress. So it is a line along this axis, sigma axis. Okay, this is means this is the direction. You cannot get it. Look, this is the direction. Sigma. Now, what is the elastic body? Linear elastic body. Linear elastic body, just simple up to proportional limit, up to elastic limit it is, and the value is a straight line, and you can obtain modulus of elasticity. Okay. Now second, uh, elastoplastic. Go with the name. Everything is written in the name. Elastoplastic. Elasto means elastic and plasto means plastic. This is elasto, it is elastic, and then it is plastic. And what is the meaning of plastic? Plastic means deformation is very rapid. Okay, this is elastoplastic behavior. Please draw it on your copy. It will come in sometimes in your exams. Okay, I am moving ahead. I hope everyone is drawing it. Now, I am going with perfectly plastic. Perfectly plastic. For perfectly plastic, it should be like this. Okay, perfectly plastic means it should be like this. This means large number of deformation for same amount of stress. Okay, and this is now one more thing: elastoplastic with strain hardening. So this is like sigma epsilon, and it will go like this. Although it is in plastic, but plastic with strain hardening, hence it will go like this. So these few things you need to remember, and this will help you because it will come directly in your exam. And one more thing that I want to emphasize on you. Uh, so one thing is, suppose you have a irregular object, that is conical object, and you apply load P. What is the elongation? That may be the question. What is the elongation? Suppose this is diameter D1, this is diameter D2. Please memorize this formula. Delta L is equal to P L upon pi by 4 D1 D2 E. Please remember this formula. This will come sometime. This will help you. Don't go with the derivation because derivation is quite complex. Go with the elemental part then take the elongation, then integrate around the T1 to T2. Just this is the formula. Remember this. And if T1 is equal to T2, that is the normal case, then it will be simple PL upon pi by 4 T square. It is our earlier case. So, or PL by AE. So, remember this formula. This will help you. Okay. Okay. Now, anything? Suppose, yeah, in this same problem, suppose this is given not P, it is hinged in between supports. In between supports. Okay. And the temperature is increased, delta T is increased. What is the thermal stress in this? So, first of all, you know, delta L is 4PL by pi D1 D2 E. Okay. And delta L is equal to L alpha delta T. This implies, if you just look at the both comparison, L alpha delta T is equal to 4PL upon pi D1 D2 E. And cut it, then the T force that is coming is alpha delta T pi D1 D2 upon 4 times E. Okay. Now you can ask what is the maximum stress, and you know maximum stress occurs at the minimum cross section. So this is the minimum cross section, and if you divide it by pi by 4 d1 square, and simply divide also here by pi by 4 d1 square, it will be d1 d1 cancel. It will be sigma maximum equal to alpha delta t times E d2 by d1. I hope you are getting it. Just any message, uh, just write in chat if you're getting it. Just write in chat box if you're getting. Okay. So this is a basic means starting 3 to 4 things, 4 chapters that I want to discuss. And please learn, please means you need to memorize it. You need to get understand. You need to get through it. Now let me give you something. Okay. So you are everyone is from third year or final year, right? So write in chat box only. I am asking just simply write in chat box. What is